Is Sambhav, is it?
It's a great question.
Yes, I was just setting up the live stream. 1 second.
Always like the big reveal, Sambhav. It's either you or Javier, and just keep us on our toes.
That should be easier. Okay. Should be it. Okay. Hello, everyone. There is a document attached to this meeting. Please sign in and put any agenda items on there. We'll get started in a minute. Okay, let's get started. Let's see. First item is to claim the host controls and start the stream. We're done. Next up, new faces. I do see a few new people. Manuel, do you want to introduce yourself?
Yeah, sure. Hi, I'm Manuel Fuchs. I work at Salesforce with Terence, where I maintain the Java build packs and recently spearheading, you could say, like our Rust framework to write build packs in.
Great to have
Someone's
you.
had a fun week.
Yeah.
We can also introduce ourselves. I'm Sam. I'm one of the maintainers on the build packs project, and I work at Bloomberg in their ML platform team.
I'm Terrence, also a maintainer on the build packs authors toolings team, work at Salesforce with Manuel, like you said.
I'm Forrest. I work on a team at VMware that works on Paketo build packs.
I'm Aiden. I work with Sambhav and do whatever he tells me to do.
I'm Dan. I also work at VMware and work on Paketo build packs.
And I'm David. I work at VMware too. Also on the Paketo build packs and the Java build packs specifically.
Great. Let's get the ball rolling. Status updates. Don't think there have been any significant ones on the Loop CNB side. I know Forrest put in a couple of PRs to update the V2 alpha branch to, I guess, to make it closer or easier to integrate with whatever interface packet has right now.
on that front, I finally did get the opportunity to try and convert one of our build packs and packet itself to using libc. I have a branch pushed up on packet right now that can be exclusive branch, so it's using anything like that. It's not 100% perfect because I was just trying to spike a bunch of stuff out. So there's very obviously no SBOM usage right now, and there's still some other like assumed structures, but it was not as frustrating as I was concerned it was going to be.
That's good news. What else? Anything else, Daniel? If I missed anything?
I don't think I have any updates. It's been a busy week in other areas, so I haven't had much chance to look into build pack stuff.
Cool. Next up, I think we have standing RFCs on the agenda, and if no one else has any agenda items, I think we might be calling it early today. Let's see. I don't see anything new here. There is this additional exportable layers RFC which I updated. Which sort of spun off from an idea that like we should be able to export additional layers apart from just the layers directory and the workspace directory. I don't think I've discussed it yet in the working group with the new proposal. I'm waiting for the rest of the people to come back so that we can
Do you
go
want
through
to
this.
talk about it at all here before the big working group?
Would
Want to hold on?
would people be interested? Like, is this something? Okay.
I mean, I feel like it has large implications for build pack authors. So
So what's the idea? The idea is that there are like the build packs API is limited in terms of what kind of file system changes you can make through build packs itself. This is regarding the new Docker files RFC. But there are often like tools or ecosystems that require files or things to be in a certain place. And not every one of them are so portable or relocatable that you can put things under like layers or workspace. There are times when you have to use a specific directory like opt, or like even preserve some settings on the home directory, for example. Like I know certain tools do not like take in environment variables, and they have like hard-coded paths on the home directory where they like to read the configuration from and things like that. And if you want to do that for the runtime user, it's not easy to put these config files in the run image. So what's the idea? The idea is that as a build pack, you can now specify in your build pack toml some additional volumes apart from the app directory that you'd like to export. The original motivation was this, but then there were some other use cases that came forward. Like there are often times when like you have multiple build packs reading from the same source directory, and then like one build pack may go ahead and wipe the entire source directory after it's done building, and then the next build pack has nothing to work on. So let's say you're trying to build an application that has a JavaScript front end and a Go backend. Go build packs will often go ahead and wipe out the entire like source directory, whereas the Node build packs might need that to do other things like npm install or whatever. So you have to take care of things like preserving order and knowing when to do app like workspace modification so that the rest of the build packs still are able to detect and build upon the remains of the app directory. So the idea was that you could declare these additional volumes by name. So you could do something like, hey, as this build pack, I'm declaring a volume called AWS extensions or user config directory or something like that. And then at the run image or the builder image level, you can set labels that map these things to a specific value. So you can have the build pack be like, or like multiple different build packs be like, I just want to write to the user config directory, but based on the stack, it might be home/cnb.config for one stack, or it might be some other user if the stack is entirely different. So the idea is that you'll need two pieces of information. One is this, and the other is this mapping. This mapping is optional, and if not provided, it just defaults to this new directory, which is called workspaces / the volume name that's specified here. So the idea would be that instead of a singular workspace directory where we mount everything and output everything, there would be a workspaces directory, and each of these volumes would be subdirectories under there by default. And the current workspace directory would just be symlink to workspaces / default. There were multiple restrictions around this RFC, which is like making it easier for platforms like Tekton or other things to implement it using a single volume, making it configurable so that the build pack is not coupled directly with the stack, and you can change the mapping of these volumes based on the stack and what it's compatible with, and while still allowing like build packs to declare like a common set of volumes they want to work upon and write. There's one more extension to this that I've not yet proposed in this, but in the future, what we wanted to do was mount the app source code as a read-only volume that all build packs detect and build upon, but the output does not modify the app source code. So the idea would be that subsequent build packs can have one or more than one output directories where they can produce outputs in, but the pristine input source code is not changed, and that's removed at the end of the image creation. So you don't end up with unnecessary garbage in the output image, only the files that the build packs chose to put in the output image. I didn't put it here because it had a bunch of backwards incompatibility things to go through, and we wanted to go through this step by step, but that's what this current RFC is.
Are there concerns around, like, say you're doing a thing for this AWS extensions and you hard coded it to /opt, and the run image doesn't specify it, so it goes into that workspaces directory? Is that a concern at all as a build pack author, or is it just like this build pack expects us to be in /opt, and that's fine because I work at a company where we can control basically the run image. So and I guess as a build pack you could also specify, I guess with stacks maybe going away that's less true, but I guess before that stuff gets done, you could specify the stack it supports, right? But maybe that's less true in the future.
Yeah, I had this clause to again, I've not included a bunch of things because people were super opposed to build packs declaring which directory paths they want to write out to. could add a way to default these to certain values in the build pack toml. So you could, so instead of the default being workspaces / something, the default could be /opt. And then the lifecycle can like simply create the appropriate symlinks and directory permissions when things are being built. And the output would still be preserved, because the way the lifecycle would do this is it will use the mounted workspaces volume, create this exportable volume name based on this, and then symlink the default path like /opt to this place. So for the build pack, it would look like it's writing to wherever, but it will go to the appropriate path in the output image through a symlink.
Yeah, I mean, I think what you have is definitely the cleaner design. I'm just wondering how much of a concern that is. Like, if you intend it to be in a specific directory, you might have pre-compiled binaries that have prefixes or something, where it obviously, if you don't put it there, it would break, but there's no way to kind of communicate that up, right?
Yeah.
I don't know if that applies like in this particular example you had, or the use cases you had at Bloomberg that are kind of driving this stuff, but obviously on Bloomberg, you kind of control that, so it doesn't actually matter in practice, but
yeah,
it does, I think, hurt portability if that does matter. I don't know how much of a concern that is.
I mean, I don't have any strong opinions, like in terms of hurting portability. I have yet to see build packs being used by someone who didn't know what the build pack, like it's either an operator taking a build pack from someone else and then adapting it to their stack, or like the build pack shipping with a set of base images or a builder image that it's compatible with. I've never seen people go like search the internet for a random build pack and put it in my current builder or stack or whatever. So I'm not sure how applicable that would be. And in some cases, the build pack would have access to the information it would choose to like just not run if it doesn't find the appropriate things.
Can it detect? Is there? I guess I don't know if I see this in here. Can you detect? I guess you get access to where this folder is, so you could just check.
Yeah, I still
and fail.
I should add those parts, but the whatever exportable volumes is like, this specific thing would be passed to the build pack during detect and build. So like if it declare that it's using the specific named volume or whatever you want to call it, this is the value it's been mapped out to. So it's similar in the sense that it's the same way to set it on a base image, and it's also the way it will be exposed, except it'll be filtered down to the volumes that the build pack is interested in. I thought I'd added that, but it's not there. I'll update that, but these would be passed during detect and build.
There are concerns with this in rebase and the way the layers kind of can write to arbitrary locations.
In what sense?
Well, I mean, if I, as a build pack, wanted to put Java in /user/ whatever, I could do that now, but that's going to kill rebase because that's not a clean path anymore.
I think it's mitigated because the run image gets to dictate where stuff goes.
Yeah.
So I imagine if you did that, yes, you were probably screwing yourself in that case, but you explicitly chose to do that. I imagine, I think probably the world is like you're putting stuff in places that hopefully don't impact rebase, but I mean, I guess there is that risk if the run image chooses to do that.
So as the build pack author, I couldn't choose to do that but the person that's packing things together into a builder
Yes.
could potentially choose to do that.
Yeah, but I added this specific part, like when creating a builder pack or the platform would validate, when creating the builder, it would validate that those things don't have anything there.
Okay, so
Rather
it would fail if that directory existed already.
Yeah, for during builder creation, not during build. So
Okay.
yeah,
Would there be a SHA associated with the volume name? Again, just thinking about that situation where you've got a dodgy build pack that tries to replace user config dir in a subsequent build with something that contains a different set of contents.
all of these volumes follow the app directory like lifecycle where all the build packs can together collaborate on it and they're wiped after each build. There's no restore process.
Okay.
So whatever is applicable to the current app directory would be applicable to all of these volumes. The semantics are the same. It's just instead of one workspace, you'll have n workspaces, which can be at different paths.
But those exportable volumes are only around for that particular build pack.
No, they're shared. So like same concept as the app directory. Nothing changes. It's just multiple ones. And
so if you have a build pack that has AWS extensions and I have a build pack that also does different AWS extensions, then we have a collision.
If yes,
if we try to use them together.
Yep, like they'll have to coordinate together the same way build packs currently do on the app directory. So like currently, if the Go build pack goes ahead and wipes everything in the app directory, there's nothing the node build pack can do. And so similarly,
do you think there could be an advantage to like prefixing, slash workspaces slash build pack ID slash exportable volume name or something like that to namespace it, or is that just too complicated?
I think that might be too complicated because these are supposed to be shared directories where build packs can coordinate together. You can always, I guess I could put one thing in there. If the names are different and the values are mapped to the same thing, might not make sense. So if you have AWS extensions and then another build pack has like Java extensions and they're both mapped to auth, that seems weird.
I could see that being an issue.
So it should instead be like both say AWS extensions, then they both know that there's a common thing that's valid and they should be able to collaborate. You can also I can also make these namespace. It can be something like Paketo / AWS extensions. That way you know that all the Paketo, these are like free form names, so you can put whatever you want in there. We could make it namespaced so that like build packs with the same namespace as the volume namespace can write or something, but I don't know how much of an issue that would be. You can
it seems like an edge case, but
you can
curious.
always choose to put like a unique name there and make sure that your family of build packs reuse that unique name across things. It's the same way as the provides and requires currently work, I guess.
Yeah, it might be just interesting, or it might be just helpful to add to the proposal some of these edge cases and just your thoughts on it. That way, like if someone has a question about that, going back, they can just see, oh yeah, it's just intended to be that way.
Yep.
I'm not sure I quite understand the intention of not having these be layers, but instead having them be directories off the workspace. It seems like it kind of would limit at least my usage of it, because I like to try and put all of my dependencies, or as many as I can, in layers so that I can reuse them and not have to re-download them. Can you just talk through that motivation real quickly?
you can still do that with this the same way you reuse that currently with the app directory. You can store the built artifacts in your layers. It's just you can put them, symlink them back or copy them to these specific directories. The reason I didn't want to treat them as layers is because then you get into the whole restore, like how do you restore a shared directory that multiple build packs have worked upon? Like each of them will have to do some own bookkeeping to figure out whether to delete certain things or add certain things. So it's always easier to just restrict all of that logic to the build pack specific layer directory. And then if they find that this common workspace is something that they want to copy things out into, they can do that during each build.
So like this is really to facilitate like if my hands are really tied on where AWS extensions are looking for, that sort of thing. Okay. Yeah. I got you. I was being a little greedy and hoping to be able to solve some other problems that I'm having, but I don't think that it's quite right for those.
It's mainly so the support Docker files RFC allows for some of this, but it might lead to some performance degradation since you're doing run image extensions and all of these things. And it also doesn't handle rebase. The way it handles rebase right now is like we rebuild the base image reusing some of the older layers or something. Like the specifics around rebase and the Docker files RFC are still up in the air. The other thing is all of those extensions take place before the build process. So let's say you build something and you want to put something somewhere and still have it be replaceable. There's still gaps around that.
Yeah, this just gives me a key to my handcuffs as opposed to like a 100% new avenue. I think that's a better way of thinking about it.
For the go ahead.
I was going to ask about permissions. Since some of these locations that you could put files like /opt are typically owned by root, how do the permissions get set? Because like right now, like if you write something to layers, it's all the CNB user.
Yeah.
Can that get controlled somehow?
So the way it will be controlled is the way Lifecycle currently makes sure that you have access to the workspace. Like you have appropriate permissions to the workspace. So all of these would be originally directories and workspaces / the directory name, and the lifecycle is just responsible for creating symlinks, assuming there's nothing there already. When it's creating symlinks, you'll get the permissions from the workspaces volume carried over.
No, I was asking in the resulting image, who will be the owner of those files? Be the CNB user?
Yeah,
basically.
the build time user. Yeah.
Okay.
Yeah. So that's also why it goes back to like that different build time and runtime user thing we have, where the build time user is different from the runtime user. You can have the build time, like using root as a user during build essentially ensures that any other random runtime user can't modify those things. Having a different build time and runtime users with control permissions sort of achieves the same thing. So
yeah, I see what you're saying. So as long as you're following that practice, it should still be locked down.
Yep.
For restore stuff, do build packs just basically have to redo the thing every build then, because it can't be shared?
For resource stuff as a
restore, like
okay,
restore, it doesn't basically the baseline.
For restore, I guess the way it would work is you compile like whatever assets you want to restore, you put them in your layers directory, and then your build process does the job of like either copying or symlinking these things over to the app directory. So it's on you the same way. Right now, if you're doing anything with the app directory, it's on you. So like you.
Okay. So it has the same properties, right? Like you basically have to rebuild it or reproduce it. And so like you can imagine a build pack author guide around this feature if it was in to basically advise you to, if you want to cache stuff, like use a layers directory that then copies stuff over, kind of maintains that.
We already have like I know like our .NET build pack currently already does this. We have a series of layers and we co-locate all of the contents of those layers into the workspace using symlinks so that we can do both. So I think it makes sense in terms of a workflow. It's a little clunky, but it's kind of the way you have to do it.
I think Java build packs do something similar, if I'm not wrong. I think these are all optional features, so it wouldn't impact anyone yet. The future extension to it, which was like read-only app source and then empty workspace directory, which I don't know what people's thoughts are on that. Like in at least the way I've looked at it, like making the place where you take the user's input application and then having that be the same place where you output artifacts has led to some issues where like users can control or like leave random files around, and if the build pack isn't aware, it will just keep them around. So it's more like if we did it the other way around, where the app source code is just mounted as a volume read only, and only the files that the build pack is interested in get carried over, it might be useful, and it might also help multiple build packs coordinate together. So like makes sure that build packs can't arbitrarily just delete things in the app directory, and then the next build pack doesn't have a way of figuring out what to do.
I think I like the general idea. I like the idea of having more removal of source code baked into the build pack process in some ways. I'm a little concerned about having it be baked in so that it's remove all, because I think sometimes like, a fair amount of the build packs that I work on are obviously build packs that build a compiled artifact. So you don't really need any of the source code at the end unless the user has static assets that they're referencing or something to that effect. But for a lot of interpreted languages that I work on, Node.js, Python, Ruby, it's kind of hard for us to determine like in any good way other than I want the entire workspace that of what I want as the user. So like I know that in implementations that I've worked on, have done sort of in very specific scenarios, we assume removal of everything and then allow to keep. But other than that, we sort of are like, okay, here's a series of files that I would like to keep or I would like to be excluded instead. It really depends on what language framework you're working in.
And with like, again, that would be up to the build pack then, right? Like the Python build pack could say, I'm copying over everything from this read-only directory onto this output. It's just that it made the explicit choice of copying everything to the output.
And so then is it on like an individual build pack level to also then have an implementation that would allow a user to say, so like a good example of this would be like, say I have a node front end that transpiles into static assets that I've done on like HTTPD or something like that, right? Is it then on the build pack to basically say, okay, node in its build process says it wanted everything, but I don't actually want everything. I only want, the public file that was generated and the HTTPD config or whatever. How do you like reconcile doing the merge of those two then?
So that's where the like these multiple exportable volumes. So in that future case, which I've not yet proposed in this RFC, the idea would be that so let's say there's a workspaces directory for Node where it copies over everything. If some other build pack wants to collaborate on that workspace directory, it'll just say like, hey, that's one of that's one of the things I want to collaborate on and put that here. If it doesn't want to do that, Node build pack can copy over everything what it likes in that directory. And this other build pack can just look at the source code and copy the specific parts it wants into a different workspace directory. And then based on which process is invoked. So you remember you put in that RFC to have process launched in a specific workspace directory. So like your other build pack can be like, I want to launch my stuff in this directory with this, with this limited workspace stuff. And the Node build pack can be like, no, my workspace or the processes, my process will launch in this directory with all of these files or something like that. And if they want to collaborate on things together, then they say like, okay, the common directory is like web workspace or something like that. So web is where Node and HTTPD collaborate or something like that.
I think the idea is interesting. I probably shouldn't speculate it too much, considering there's not actually an RFC written. So
the other one,
I was going to say, a couple of things that bother me about it. It seems like it adds a lot of copying, and you have an arbitrary amount of files that an application could be. And if I now have to copy those every time, that could add, if you have an application with a gigabyte of files, that's going to add a couple seconds to every build. So that's a concern. I do like the idea of having some sort of fixed original, copy of things, because there are times where I'm like, oh crap, I deleted that already. I can't get the POM file anymore or something like that. And it's just inconvenient to work around. So yeah, like I do like that, if there's like a workspaces original that or something, that's always there and always read only, that you could count on, that would be kind of cool. But yeah, I could see some advantages, if it's like each build pack has its own workspace, and then there's this, there's the output directory where you have to put stuff out, some of that coordination you were talking about seems good. I just concerns about performance, I think.
I mean, the reason I didn't write that yet is because we were like still unsure on how that would be perceived. And you could also have an implementation where as you said, in order to keep things the way they are right now for backwards compatibility, we copy, we mount two volumes, one which is read only, and has all the source code, and the same thing with the write only volume in the default workspace. So the build packs that function as they do right now, they'll see that common workspace fully populated and writable, and they'll do modifications as usual. Once things get deleted, they won't know what to do with the rest of the process. So, but the new build packs that rely on these two different directories, they could still reference back the original source code as read-only version and put things back in the writable directory if they want. So that's the alternative, where you mount two things. One is read-only, one is the common write-only thing with the same contents. But yeah, this is all I'm thinking out loud, but
yeah, absolutely. No, it seems interesting. Yeah, I look forward to seeing something more.
But this RFC, if there are any additional comments, and still trying to polish it up a bit. It's not its final version yet. I just wanted something that I could talk around in a working group and use the feedback to improve it.
Does this, I know in the past you've had a bunch of RFCs kind of in this vein that I think we closed a handful of them. Does this address some of the issues you had with the read-only layer stuff with Python and having multiple build packs kind of modifying and touching?
This does not address that, no. The read-only issue is still there. That's very much still an issue. I don't know a good way to solve that without
making it read-only.
Yeah. This was more to solve the issue where certain applications need to be in certain paths, and I don't want to use I don't want to do image extensions to just have them be there, because like it's not that I need root, it's not that I'm overwriting existing files in the base image. It's an empty directory. I just want to write something in there and export it out.
Is it mostly like the AWS extension stuff, or there's some
Yeah.
like other open source kind of things that also kind of exhibit
I know-
this behavior for your
I know
use cases?
the Keto Java build packs currently do some magic to restore things from the home, like they symlink the home directory to something. I don't
For like M2 cache.
for cache, and I don't know if for anything else. The other thing was like settings or things in the home directory for the run image. So like let's say you're setting certain config values like the AWS host or something in the output home directory.aws/settings or whatever. So like those things currently, the way you have to do them is through an execd or profile D helper, which during runtime writes them to the home directory, even though they're static, non-secret type of config files. So instead of writing a profile D or execd helper to do that during every launch, you could just put the files in there and forget about it. I don't know of any other such things. One other thing that does something similar is like Red Hat extension packages. They do something like /opt/rh/ some random prefix, install things there. I don't know if this will be useful for them, but that's like the other place I've seen that pattern being used, where like they'll install like Git, the new version of Git that doesn't ship by default and in their RPM distribution or whatever, and they'll install it in opt/rh Git 227, and then that has the whole directory tree, and they put like some activate script or something to set the environment variables.
For the Red Hat stuff, would you not do that as a run extension though?
You
Or is it pretty common to do that at the user level too?
So I think you would definitely for that stuff. I am not an expert on Red Hat stuff. I've just seen that pattern, so probably want to do it as an image extension. I don't know if it touches any other files, but that's the other place where I've seen like individual files living in some specified subdirectory that is not like user var or something like that. I don't know of any other things.
Gotcha. Yeah, I mean, I know for me and probably some others, something that would be helpful in this RFC beyond kind of the example you have would just be like what the use cases, like practical use cases of things that kind of require or use this thing. Because I imagine, I feel like this past year for CNB has just been feature creep and scope is so large. We're trying to cut all these things out of the API, like, bash and other things. So I definitely think that would help kind of the RFC of, not that this isn't a useful feature, it doesn't have things, just like being able to enumerate it more explicitly instead of people having to kind of imagine and kind of create that in their head.
Yep.
Because it's clear, like you, besides the AWS stuff, like there's clear use cases, and it'd be helpful to just pen that down.
This specific thing is motivated by an internal use case. I don't know how much I can talk about it, but this would essentially unlock things, unlock a huge portion of things for us, and that will allow us to use build packs for like certain other kind of applications.
Is there ways you can talk about it that is more, I guess, like
that's
high brushstroke, I guess, that doesn't talk about?
That's what the current RFC has in its motivations.
Gotcha. I see.
But it's somewhat of a similar use case where it just needs to be under a certain directory tree. It doesn't care.
Like you don't control that internally, right? Like you just have to abide by some standard that's set by not you.
Yeah.
Right. Essentially is the use case, right? Okay.
And the good thing is that directory tree is completely like it's isolated to that directory tree, it doesn't touch anything else. So.
Yeah, I mean, I even think, do you say that in the RFC? I think I might have not seen that, but I think that's like, without going to any other details, just like, like there is a thing we don't control, similar to the AWS whatever thing, like, and in order to make stuff work in certain kind of companies, like to make build packs be viable in like as a platform, like it's not negotiable for us, like it has to work this way, right?
Yep.
Like I even think that would be helpful without going to any other specifics.
To add that, I mean, I always like there are always other workarounds, but it's just annoying.
Yeah, I'm assuming you're working around some of it today in pretty hacky ways. So
yep.
Cool. Were there any other RFCs or things that you want to touch on before we kind of closed out for the rest of the year?
There's the run images from RFC that had a few updates. Natalie and I were trying to brainstorm how we could do this in the support Docker files use case. There is a Slack thread here. But the idea would be that the gen packages binary, I don't know how much context everyone has around the support Docker files in this run image RFC. If not, let me know, I can do a quick recap.
I imagine at least Manuel probably doesn't have context.
Correct.
So the idea is that we currently output bill of materials through build packs, and the like build pack specific, but we don't have one for the run image. And a build pack couldn't just scan the whole run image and generate one, because like it might be rebased or some other random things. So the idea was like for the run image to have its own SBOM somewhere that is attached to the run image, so that when you do a rebase, once the new run image kicks in, the new SBOM attached to the run image will also kick in some way. The difficulties were around like how do you attach this bill of materials file so that it makes it easier for the lifecycle to like do some sort of merge operations or restore it or do any bunch of other things. And then also how it plays with the other Docker files RFC, which involves dynamically installing applications. How do you then generate an inventory of all of those applications while it's being generated without embedding some weird binary that does it in the output image or something like that. So the current idea has been that like we take the input image, pack has an additional command called pack attach SBOM or something, which will take an input image reference, the bill of materials that you want to attach to the image as a single file, and then create that output file, which you can then push and publish and use as a run image. The exact specifics around it is that like pack will put the output SBOM under CNB SBOM, and then like the SBOM file name, and then store that in a separate layer, the diff ID of which is stored in a label, so that lifecycle can use it to restore or merge things if it needs to in the future. And the same thing for the Docker files RFC would involve that. So the other RFC currently proposes that there's a gen packages binary that's embedded into the build image and the run image, which can scan the entire image and produce the bill of materials somewhere. That wouldn't quite work with this approach where we want the bill of materials to be a separate layer and to know the diff ID of that specific layer to attach it as a label, because Docker files don't have a way to introspect these kind of values like diff IDs. So the final idea that Natalie and I had was that you can just attach or put this gen packages binary in the builder or on a separate volume that doesn't end up in the build image or the run image. Sorry, in the run image, and then this binary can scan the files on disk and output it somewhere. And then when the lifecycle is exporting the new extended run image, it can use the same process that pack is doing right here to attach the outputted SBOM on file on disk to the run image. So those were sort of the updates. If anyone has been following this thread. Any questions, thoughts?
Yeah. At some point we should talk about caching again. Maybe in the new year. Figure that out.
Yes. I think Natalie was the last person that like was handed over like the whole cache stuff from Emily, and then no one really took over because like all
okay.
of us had partial
we
knowledge.
Could just wait for Emily to come back. She texted me last night, so she's alive and well, and she may be coming
It's
back
good to know.
in the new year.
Nice.
Yeah, I think on the topic of caching too is like we had that whole asset packaging RFC that got approved, but then didn't really go anywhere. And
The Daniels RFC.
Yeah, I don't think it goes quite far enough to be useful, at least for the purposes we need on Paketo. So I think having a larger discussion about asset management kind of fits into caching too, and trying to understand people's needs there.
Yeah, I do think if anything, a lot of that should be driven out of this working group because of I do think a lot of that caching concerns come from bill pack authors trying to do things, or I guess in the case of caching, not do things.
Yeah,
Safe space.
and I'm motivated because we have a bunch of code that does all that in a bad way now and stuffs things into images, and I'd love to be able to get rid of all that and just have it be simpler. So yeah, motivation.
Are your caching concerns shared across all of Paketo, like both the Java and the non-Java side, or are they also different, or you haven't talked about it?
I don't want to totally speak for Forrest, but I think we have similar implementations of how we download and cache and store things in the images. They're not, I highly doubt they're compatible doing the same thing, but they're at a high level the same. And I think we have similar caching issues too, in that like we want to have a goal of like a binary gets downloaded once, for a user, and they don't have to download it multiple times because they decided to build two different apps, or something like that. So I think there are some shared concerns. I don't know, Forrest, what are your thoughts?
For sure, like not having to download the binary a bunch of times is definitely something that is interesting. The biggest use case that we're worried about is enabling customers in air-gapped environments to continue to use build packs, I would say. Or customers, users, any of those. You're correct, Dan. We do have a very similar implementation in how we just kind of shove a bunch of binary or compressed binaries into images, and it's pretty ugly. So if we could move away from that, that'd be really cool.
Yeah, and that creates some performance issues for us. It creates some size issues. The images that get created are gigantic. It's hard to share things. Like if if Forest has a build pack that includes Java and I need to include Java, those aren't the same layer. And so they, then things get bloated really fast. There's a lot of concerns like that.
In your use case, Force, is that it feels like the asset cache thing that Daniel came up with, at least definitely came from that spirit of trying to address probably the air gap. I feel like air gap was definitely at the heart of that proposal.
For sure. Daniel was working on Paqueta before moving into focusing more directly on CNB, and we started that RFC while he was still on Paqueta. So it was more focused on air gapping, but I think that there's definitely going to be like issues in the future when it comes to like we're already hitting weird sizes with our builders already, and so it's only a matter of time before it gets even
How big
worse.
are your builders? Just out of curiosity.
Builders that don't even have all of the like things vendored into them are already in like the magnitudes of hundreds of layers and hitting hundreds of megabytes, pushing on the fatter side of half a gig, and that's just binaries that we're trying to get into the same place.
Anything else? Gotcha.
Yeah. So it will be difficult, and there's not a great way of sort of allowing users to do a own set of dependencies as well.
Yeah.
So
the other side of this, or like maybe it's not something that we as a project have to solve. There's one other thing that has come up in the discussion around this in the past is like the E-star layers, or the lazy pulling capabilities, where you can bundle these layers in the output image, but they're not pulled in until they're read. So your image still small and for the minimal functionality that is needed, and the assets that you have will only be pulled in when they're read. So you can transport the whole image to a registry. It's still air gapped. When they pull from it, they'll only pull the necessary layers that the build pack detects. So if the Java build pack is detected and it needs access to the JRE or the JDK, it will try to read that from that specific part of the output image, and that's what will trigger the pull of that specific layer. I'm not sure if there are any layer restrictions on this sort of overlay, but I'm guessing like since you're not overlaying all the layers in the beginning, you won't end up with 128. That's more of a Unix restriction, I guess, than the overlay restriction. But I'm guessing that's the limit you're talking about, right?
For sure. I mean, like that is a limit we're talking about, but it's not the one I'm the most concerned about. I guess it is just like the bloat that we have in terms of like we've tried to build out a more modular system, which I think has given us a lot of advantages, but there's just overhead to doing that. And so with that overhead, we're trying to sort of say, well, we don't want to make you have to pull these sort of monolithic collections of build packs anymore. And so finding a way to build those out in ways that don't have to be monolithic is like non-trivial. And the one that is obviously, I think, hurting us the most right now is that it's hard for us to get these air gapped systems set up in ways that are easy for users to like engage with, but also like robust and composable.
This is what I was talking about, by the way. This way, I don't know if this came up in the discussion in the past, but
it's been a little while since we've had deep discussions about this as well. So I'm,
yeah, I didn't mean to start us on that whole kind of thing, but I know we're at time, but looking forward to continuing this in the new year, and hopefully we can actually do something about it. Yes, enjoy the holidays, get some rest and recovery, and looking forward to working with everyone in the new year.